Thank you everyone for joining this online workshop on farm infrastructure and pesticide handling. And of course, this is part of our project with Thames Water. We're pleased that we've got Jeremy Van Ginneken from Thames on the call with us today. Now we'll be looking at the things that you need to consider when undertaking yard improvements and what to do, which will help to manage water usage and improve water quality. So examples will be rainwater harvesting, concrete yard renewal, pesticide handling areas. As we go through the workshop, please put your questions in the chat and we'll pick them up afterwards. So just to get started, I'm really pleased to introduce our speaker, Mell Holloway. Many of you will already know Mell from earlier work with Thames and possibly also with her work with ADAS. She's now an independent consultant, but she started in farm management and then was with ADAS for over 20 years, I think, and is a basis soil and water, basis conservation management and FACTS qualified advisor. And she's got plenty of experience in presenting this sort of workshop. So over to you, Mell.
That's very kind of you. Thank you, Elizabeth. Right, so I shall just share my screen. Okay. Right, well, thank you very much, everyone. I'm primarily going to concentrate on pesticide handling areas and chemical storage in the yard. The first thing I'll say is that there is a huge amount of advice and support available. Some of you may have already benefited from the Thames Water initiatives with the technical advice and the catchment fund advice. That is still available, and there will be another round of applications in November, I believe. So, you know, if this is something that's of interest, you'd like to look at what might be suitable or practical on your farm, then do please get in touch. So what I'm going to do is I'm going to think about the issues that we see in the farmyard, what those consequences are, and then what can we do on farm. And what I want to do is concentrate on practical solutions, and the solution for one farm may not be the solution for another, but I think there's lots of things that we can think about and learn about. I'm going to talk about the design considerations if you're looking at putting in a bespoke filling area, and also the legislative requirements as well. And these are things that we can look at individually on your own farms as well. So just thinking about the issues, if we're thinking about the chemicals in water to meet the drinking water standard, it's 0.1 parts per billion, and this is an absolutely tiny amount. And so you've probably sort of heard these ones before, but it sort of puts it into context. So in just 1 second, 2 sprayer nozzles can deliver enough pesticide that could exceed this standard in 1.5 miles of water in a large brook or river. So, and obviously at that point, the chemical is diluted. Another equivalent, 1 grain of wheat in 390 tons, or a stem of hay in that huge pile. So it really is a small amount, and we all have to think about what we can do to help with this. So if we're thinking about sources of pesticide in water, we can obviously have issues with drift and through unintentional direct application. We can think about a source as being surface water runoff and through drainage. We've got yard and filling area losses, and we can have losses from the muddy wheels of sprayers or tractors, hopefully not as muddy as the sprayer that we see in the bottom left-hand side there. So this is some research that was done in the Cherwell. This was some years ago, but this research has been replicated in other areas. And it shows there the sources of pesticide pollution other than application. So that's excluding spray drift and that sort of thing. And we can see there that almost 80% of it comes from the filling point. So we've got the washings that we just talked about. We've got the washings from tanks, from containers, from foil seals and so on. So it is a very large proportion. And obviously at the filling point, that's when we're dealing with the concentrated chemicals. So it is the highest risk operation. So what I usually say is, if I'm going out onto farm, it's a series of questions. The first one is, where and how do you fill the sprayer? So is that out in the field? If it's out in the field, is that an undrained area? Are we well away from any sources of surface water? Are we using a closed transfer system? So we're minimizing the issues of spills or drips or splashes. Wherever we're filling, if it's not on a bunded area, then we should really be using a drip tray. And don't forget, it's not just a tractor mounted or a self-propelled or trailed sprayer. We've got to think about knapsack sprayers as well. So are we filling that in a tray, or is that just placed on the ground where we could have some drips and splashes? The next thing to think about is what happens to our foils, our seals, our empty containers and our lids. Obviously some rather extreme examples in there, but you know, in between each sprayer run, are we putting away chemicals? Do we have things like mixing jugs and that sort of thing that are left outside where they could be a potential risk? What are we doing with our old chemicals that are no longer in use or are no longer required on farm? Are these being disposed of via a waste contractor? And there are often pesticide amnesty schemes, so you can get rid of those at no cost to yourself. The next thing to think about is where do you wash the tractor and or the sprayer? So again, is that out in a field? So we're well away from drains and surface water and that sort of thing. Are we in a yard? If so, where is that water going? Do we have yard drains? Are we on hardcore where it could seep into the ground, or could there be overland runoff? So then ultimately we've got to think about where does that liquid go? So is it reaching drains? Is it reaching ditches? Do we have soakaways? Is it running down a yard? And then ultimately, where does it end up? Because the most likely thing is that that is going to end up either in surface water or in groundwater. So that's the sort of things to think about. The first thing that I'll talk about is the filling area itself. So what we're talking about as the most safest form of filling is to have a completely bunded filling area that gives us enough room to be able to park the sprayer on, to be able to work around it, to carry out the filling and the washdown operations, and to have all of that liquid contained within that area. So if we're talking about any sort of sprayer setup, I would usually say that the minimum area you should be looking at will be 12 meters by 6 meters. So that is enough room to hold the largest of sprayers. There's no point having something smaller than that, because it's really a good opportunity to be able to work around, maybe have a mixing table and a container drainage facility and so on in the same place. So better to think bigger rather than smaller. And the way you lay it out is entirely up to you. When I'm thinking about a washdown area, we're thinking about in the unlikely event that we blew a pipe and the entire contents of the sprayer tank emptied onto that area, could we contain it? Now, if we've got a bunded spraying area, 12 meters by 6 meters, and we've got a good 10 centimeter high bund all the way around, then that's going to be ample capacity to be able to hold the contents of even the largest sprayer. And we combine that with a holding tank, which I'll come on to in a moment. So you can see on the left-hand side on the diagram, that is the sort of sprayer filling area that I'm quite keen on. So on this one, we have the central drain, and it's nice and wide. You want that to be a good shovel's width so that you can lift off that grate and you can take out any sort of stones and sediment and mud and so on, so that doesn't go into the tank. And on that sort of setup, you'll have a slope going from either side into that central drain, and that will be sloping down to a tank. And if you can engineer a bit of a concrete lip on the end of that drain, then again, that will act as a sort of crude sediment trap to larger particles. In the pictures, I've got examples of a lot of different setups. So on the top left-hand side, we've got a setup where the farmer decided to bund the entire building, again with a central drain, but it was deemed easier to be able to have the whole building bunded rather than having some areas that were bunded and some that weren't. On the top right hand side, we've got a typical layout, which is an outdoor one. So we haven't got any roof over there. Now that slopes back to a drain closest to us. I'm not so keen on this type of setup, because what you've got to think about is if you had a large volume of water that you were discharging either through pressure washing or through tank washing, then that would very easily wash over the back of the bund. On the other ones, we've got one on the middle right hand side, we've got a covered setup there. You can see the ramp that goes in to that bunded filling area. Again, I'm not so keen on that because although we've got the slope upwards, if we had a lot of water spillage, then that could flow back down and out of that filling area. The bottom left-hand side, that's got nice ramps in. We can see that there's a nice high, wide bund there. We're sloping to a central drain on that one, so each corner is sloping to that central point. My only comment, and this is based on my own experience, is having a wide drain like that is very easy to lose phones and keys in and that sort of thing. So maybe something a little bit smaller. But again, you know, you might have an idea of the sort of thing that you would like to have on your farm, and that is something that you can have a visit with, and we can talk through those things. What we do have to think about is the location of that bunded filling area. So it's really important that we're not within 10 meters of any type of surface water, and we're not within 50 meters of a spring, well or borehole that will be supplying a farm. Now it's 250 meters if you have got a spring, well or borehole that's supplying domestic premises or food producing premises. So again, think about the location before you get into the detail of this. So just moving on now, so we can see a cross section of that bunded filling area. So we can see that we've got our central drain there. We have got a silt trap, so the water will bubble over and then go into a holding tank. And as far as the specification of that filling area is concerned, we're looking at least 140 mil of hardcore, then having a 25 mil sand blinding layer, a 1200 gram damp proof membrane on top of that. And then we want to have at least 150 mil of reinforced concrete that goes over the top of that. And as I say, that the bund height is important. We want at least 10 centimeters or 100 mil there, and that wants to be at least 30 centimeters wide as well. Before I move on, I can see there's some questions. Is there anything we want to look at now, Elizabeth, or shall I keep going? I'm not hearing anything. So
yeah,
perhaps...
yes, I think keep going, Mel. I don't know how many questions you can see, but I can only see one, and it's a test.
Okay, then I will keep going, and we'll do questions at the end.
Okay, just to let people know that you can, I did say put them in the chat, you can put them in the Q&A. That's probably better to do.
Okay, lovely, thank you. Okay, so if I move down now, so we've decided on the right location for our bunded filling area. We've got to think about our tank arrangements. So under the Environment Agency waste exemption that you will need to register a sprayer filling area and treatment system, and I'll talk about that process later on, the maximum amount of dilute washings that you are able to store on farm is 1,500 litres. So there's no point having an absolutely massive tank. It wants to be sensibly sized, and depending on how much volume you expect to go through and so on, the tank could be smaller than that. Thinking about the location of the tank is really important. So some people opt to have the tank underneath that filling pad, in which case you've got to think about how we're going to get the electric supply for the pump to it, and how we're going to have the input and outtake for the water. Often an offset one is going to be a more appropriate way, because obviously if you have it underneath the pad, then it needs to be reinforced and protected so that it can take the full weight of the sprayer on top. So in the setup on the diagram there, we have got an offset tank, so we can see that the water is going down into that drain. We've got a silt trap there, so it then bubbles over into the tank. Now, if you've got an offset tank, obviously the levels of your filling pad and your tank are really important, because obviously if there is a large volume of water, you want that to flow to the tank first, rather than filling up the bunded area. As far as a tank is concerned, seamless polyethylene, glass reinforced plastic, or precast concrete are all absolutely fine for this sort of thing. Don't be using a second-hand tank. It's really important that you've got something with a very long life and that is easily accessible. So if we've decided on our location, we have decided on our tank arrangements, now is a really good opportunity to be able to think about how we can make pesticide handling, sprayer filling as efficient as possible. So if you've got a nice size pad, a 12 metre by 6 metre minimum pad, then it's a good place to be able to have a mixing table. So, you know, again, if we're mixing chemicals, if we're rinsing out containers, rinsing foils, storing them, etc., then they can all be on this pad, and we don't have to worry about where that liquid is going to be going, because it will all be collected on that bunded area and into the tank. So just looking at the top left-hand photograph there, that's obviously a very modern setup in terms of chemical emptying and washing down of containers and so on. But I've seen some other farm-made ones. That the one in the middle with the blue plastic drum is a really good way of rinsing out containers. And I do like there to be a drainage rack, so we can get the absolute last dregs of liquid out. Because you know, we'll all be aware that with the best will in the world, triple rinsing, there still is going to be some residue in there. So if we can get all of that liquid out, that's better. And we can see in the middle right picture there, we've got a nice setup where we've got our drainage rack for our containers, and then adjacent to that is the storage for those empties. And again, storage of empties, it really wants to be inside, under cover, so we haven't got any risk of rainfall being able to wash residues away. The bottom right one there, that's a nice little DIY setup, stainless steel sinks. So we've got storage there. That's where we can have our jugs and containers and that sort of thing. So it's good to think about how you will operate within that area. So now I'm going to think a little bit about treatment systems. So the first thing that I'm going to talk about is a biofilter. So this sort of treatment system is going to be the best system where we have a covered filling area. And the reason for that is a biofilter is only able to deal with dilute washings. It can't deal with rainfall as well. So I would say that probably 99% of farms will opt for a biofilter rather than the biobed, but I will talk about both of them. So what we can see here is on the diagram on the left-hand side, so we've got our bunded filling area and our tank. And then we have a pump in there, and this only needs to be a relatively small pump. So we're just talking about 6.5 head, 200 watt motor, something along those lines. And that will effectively pump the liquid up into the top of this biofilter. And a biofilter is made up of a mix of straw and of topsoil and of compost. And this needs to be very well mixed together. This goes into 3 IBCs, and the microorganisms within the biomix break down the chemicals into harmless compounds. So once it has filtered through, what comes out the bottom is chemically clean. Wouldn't drink it, but it's chemically clean, and this is then appropriate to be reused for washdown, or it can be pumped to an irrigation area, as you can see on the top left of the diagram. So just having a look at how this biofilter is set up. In the diagram to the right, we can see that we've got the filling area with an offset sediment tank, and then we've got our main tank, and then we are pumping up to the top, and we've got just a sort of a grid of irrigation pipe, and that will then filter down through the biomix. Underneath that biomix, we need to have a permeable membrane, and then we want to have a layer of gravel. And this is so that we're not going to block up the pipes with silt or anything like that. Now, you'll look at the guidance for biofilters, and it will say to have a layer of permeable membrane. What I find is the easiest thing to do is to have effectively a sack of the membrane in which you put the biofilter. So you line the whole IBC and then put that membrane inside. And then that makes it a lot easier when you come to replace the biomix every 5 years, because you just disconnect the pipes and then lift out the sack. So what we've got in this diagram is we've then got another underground tank, which is taking the clean water that's coming out of the 3 IBCs. Now, the majority of people would opt just to have a 4th IBC on the bottom, so you're not needing another tank, and then it takes up less space within the bunded area. Now, because this biomix is a living mass, it needs to be kept moist all the time. So where we have our pump to pump up into the biofilter, we want to set that on a timer. So it's running maybe 2 to 3 minutes every single day, all year round, to keep that biomix moist. If we don't do that, then we're going to risk the microorganisms dying, and obviously the biomix will shrink away. So the first lot of water that will go through will just run straight through, and it won't go through that slow filtration process. Now you can see on the diagram to the left, at the top left, I've got a pump to an irrigation area. Now this is one of the options for a biofilter. It is that you then pump from your clean water tank to a vegetated area, and that would be how you would dispose of that water. Now you might have another use for it in terms of washing out containers or washing down the sprayer or something like that. But my personal preference is that that water goes back into the tank on the filling area, because, as I say, you need to always have some water to be able to send through that biofilter. And if you've got a completely covered area with a biofilter, you're going to need that water, particularly if you're just using the pad for filling and washing containers. If you're washing the sprayer out in the field, then there will be less water that will go into that system. Okay, so what we've got there is we can see the biomix there, and it would just be a case of getting the straw and the topsoil and the compost and mixing those well together and letting them weather down or compost down, because it's really important that you have a homogeneous mix there. And when we're thinking about straw, it wants to be barley or wheat straw, short chop ideally, and our topsoil doesn't want to be anything too heavy, and it doesn't want to be anything too light, because again, we want a good mix. We don't want big lumps of clay or something very light and sandy, which won't sort of bind it all together. So always make more than you think you're going to need, because you're thinking, okay, well, it's 3 cubic meters that I need for those IBCs. But actually, when you put it into the IBCs, what you want to do is water it down and let it settle down, and then add some more biomix. And you will probably find over time, within the 5-year period before you have to replace it all, that you will need to top it up. And I would say, as a minimum, you'd be wanting to look at that weathering down process as being at least 2 to 3 months. So that is our biomix. I did say that you could irrigate out the clean water. With a covered system, as I say, I would recommend that just goes back to the tank, but I will move on in a moment to bio beds, which will need an area to irrigate the clean water. So we can see here we've got a setup there where we have got irrigation pipes. They're at about a 40 centimetre spacing, with drippers at around a 1.5 litre per hour flow rate. And this would probably be looking at 1 to 1.5 hours a day, applying probably 2 to 4 mil of water. Again, I would want to have set controls on this, timers or a floating switch, and allow for override if we've got a very intense rainfall. So if I just move on now, what I'm going to talk about now is an offset biobed. Now, a biobed has exactly the same biomix inside it as a biofilter does, but what it is a big pit, effectively, and that has turf over the top of it. So the biomix is exactly the same, but what we are doing is we're creating this pit in the ground. We are lining it with an impermeable membrane, and then we have the irrigation from the tank washings that go over the top of that biobed. So we'll have our bunded filling area in an offset biobed. The biobed is going to be in another location adjacent to the pad, and then we need to dispose of that water by a drip or a sprinkler system. So this would be the sort of system if you can't have a covered area. If you have a roof, a biofilter is your option. If it's going to be an uncovered filling area, then you must be thinking about a biobed, because a biobed is sized to take into account that the rainfall that will come on the pad and on the biobed itself as well. And we can see in this setup that we will have a sump at the bottom of the biobed, so that can then be pumped out to the area that will be irrigated on. And when we're thinking about the sizing, so what you need is 1 metre square of surface area, to be able to treat 1 metre cube of liquid. So we would need to take into account the annual rainfall that's falling on the bunded area, and then the area of our biobed, and make sure that we have sufficient capacity. So just as an example, if we've got a 12 metre by 6 metre pad, we're in an area that has 883 mil of rainwater, annual rainfall. This would mean that we would need 64 metres square of surface area. Plus we've got to take into account the 15 cube of washings specifically from the sprayer and the containers and that sort of thing. So we were looking at a 79 square metre surface area, so a 9 metre by 9 metre biobed. So it just gives you an idea of the sort of area that you would need to be thinking about. So I just move on now to just thinking about the treatment systems. So we can see there that we've got our bunded filling area. It's going to that sized biobed based on the rainfall on that area and the amount of washings. And then the clean water is being pumped to the irrigation area. So that is approximately 50 metres square. And there's just some examples of offset biobeds here. They're not fancy to look at. When they first go in and you've got the you're laying the pipe down, and then you'll have the turf over the top, which helps with the absorption of rainfall. After a few years, they're going to look like the one in the bottom right. So we've got a lot of vegetation there. And that's a good sign. If we didn't have any vegetation, then that will be concerning, because we might be thinking about, well, actually, how effective is the biobed working? So the idea is that we should always have vegetation there. And as with the biofilter, this biomix will need to be replaced at least every 5 years. And that's an important thing to factor in. Obviously, with the biofilter, we disconnect the pipes and take out the biomix from the IBCs. But this one is quite a bit trickier, because obviously we're in a pit there and it's lined. It's very difficult to be able to remove that biomix without tearing the liners. So that would be a replacement cost that you would need to factor in. So we're now looking at a direct biobed. And this is where our filling area is actually over the top of the biobed. So this can decrease the area that we will actually need for the biobed, because we're only taking into account the rainfall over that area. With this sort of system, it's a very quick system because you'll drive on and off, but obviously it's not so convenient when you're thinking about the location of the chemical store, mixing tables and drainage racks and that sort of thing. And probably say the majority of people would prefer to have those undercover rather than out in the open and then having to put them away. I tend to find that biobeds are the best option for sort of specialist veg or horticultural growers, where they are doing a lot of small amounts of spray, and they're doing a lot of tank washes, and they need to be able to dispose safely of those tank washings. Whereas probably the majority of arable or grassland farmers will do the internal tank washings out in the field rather than on the bunded filling area. And we've just got some examples there of a direct biobed, so we can see the stages of construction in the middle there. We obviously need to have some steels that will be able to support the weight of the sprayer and or tractor as well. We've then got mesh that goes over the top of that, and then we will turf over the top of that as well. And again, offset from that, we want to have our irrigation area as well. In terms of the construction, we've got we've got an offset sprayer filling area. We can see the process of excavating the pit, of lining it with the plastic membrane, filling it with the biomix, and then having that irrigation pipe work on top of it. And on this setup, we can see on the bottom right-hand side, we've got the irrigation pipe work surrounding the offset biobed. Just showing two options here as far as the biobeds are concerned. So what we have in the top example is we have an internal sump with a pump within the bottom that we make within the bottom of the biobed within the liner. So that then pumps out from that sump over to the irrigation area. The other alternative is that we have a bonded outlet that is gravity fed to a tank adjacent to the biobed, and then from there we pump and send it to the irrigation area. So again, a couple of things to think about. Where we have an internal sump, then we've got less risk of there being a tear or a failure compared to a bonded outlet, which we have to obviously put in the bottom of the biobed. That's the other thing to think about biobeds as well, is that if something isn't working or we have a leak or a tear or something like that, it's very difficult to identify that. Whereas with a biofilter, because we can see all of the workings and the filtration process, it's easier to identify if we have an issue. I'm just going to talk about some other types of treatment systems as well, that they're not so common in this country. The first one is a fighter back. So what this does is work effectively like a biobed, but it is a closed system. And what we have is a mixture in there. It's 70% soil and 30% straw. And what this is doing is basically losing that liquid through evaporation. So we have a concrete chamber that can either be below ground or above ground. It has that biomix inside, and then we have a roof over the top, but this is raised, so it allows air to come through, and this encourages evaporation. So again, what we would be doing in this sort of system is we would have our offset filling area, and then we would pump over the fighter back. So this is just showing here an example of one there. So we can see that's quite large. You can see the air that will be able to flow through there. And again, the sizing of a fighter back, it will be depending on what sort of area it is. So is it open? Is it shaded partly or fully? And whereabouts it is in the country as well. And this shows that the fighter back construction. So what we've got there is we can see the biomix that's going in there. We've got the irrigation pipe work on top of that. It's a good idea to be able to have a pipe going all the way down to the bottom, so you can actually see how moist it is there. So we're not getting to a stage where we're waterlogging things. And then that roof can be raised to allow the chamber to be emptied out. So another one which I'll just talk about is a sentinel unit. This is very, very rare in this country. This is a batch treatment system, and it is based on chemical flocculation using a sealed carbon filtration that will produce a very concentrated sludge. Now, you would need a permit to dispose of the treated liquid, and the filter itself and the sludge must be disposed of by waste contractor. So this is where the cost can be quite significant. And if we were looking at 1,000 litres of dilute washings being treated, that this would result in 4 kilos of sludge. So if we're using or we're producing a lot of dilute washings, then that is going to add up. I just want to think now a little bit about chemical storage. Obviously, if we have got our filling area and we've got our treatment system sorted, it's really important that we pay just as much attention to detail to the chemical store. So you can see on the diagram to the left, what we've got there is a chemical store, and it's got 2 sets of doors. So we've got doors on the end for deliveries. You know, if we're talking about sort of pallet loads of chemicals coming, then they can go in at the end. No one's having to walk over the filling area or the pad to be able to access that store for either deliveries or for taking empties away. But we also have a personnel door which goes directly onto the filling area. So this is where we can take those chemicals out to the mixing table, over to the induction hopper, and we're not having to walk on any area with chemicals that is unbunded. The things to think about with your chemical store is that obviously it needs to be sized big enough to be able to take the peak load of chemicals with it still being safe to be able to move around. We want to have a sensible and a logical system. We want to have powders above liquids. We want to have an inventory at the store, and we want to have an inventory of chemicals away from the store as well. Important that we have some sort of spillage kit there as well. So we've got some absorbent granules on the right hand side. And the sizing of your store is dependent on the amount of chemicals that you need. So, you know, it might be that you need a full container shown in the top right, or if you store a relatively small amount of chemicals, then it could be a small cupboard or lockable store that just sits in a corner of the filling area. What is important is that chemical store must be secure, so and it must also have a bund. And if we're thinking about the bund requirements, we want to be having at least 110% of the maximum amount of chemical that we store at any time. If you're in a sensitive area as far as drinking water is concerned, or any sort of environmental designation, then you will need to have 185% bund capacity. And the sort of bunds that I prefer to have is the one shown in that cabinet, but also in that container. So it's like a cellar type bund. So there isn't a huge great lip to step over when you go into the store. You've effectively got a mesh, and the void beneath is your bund capacity. On the top left-hand side, we've got a store there, nicely organised. This was one where the farm wanted to have more of an open plan type store, so it wasn't in a separate container or a block building within the adjacent to the filling area. The only thing I would say with that is if you have that sort of arrangement, it means that the entire area must be secure. So if we've got open chemicals, it means every time you go in and out of that bunded filling area, then you need to be locking up the entire building for the security of the chemicals. You also need to think about if you're washing down in that area and it's open plan, are you going to have a problem with sort of soggy boxes and labels peeling off and that sort of thing? But it's important, whatever system you have, is that chemical store must have its own separate bund, because all the treatment systems that we've talked about will only deal with dilute washings. They won't deal with concentrated chemicals. Another thing to think about as far as the storage, as with the siting of your filling area, it needs to be at least 10 metres away from surface water, 50 metres from a spring well or borehole supplying a farm, 250 metres if it's supplying food premises or domestic premises. Even if you have only one set of doors, then make sure that those doors open directly onto the filling area again, so we're not moving over an unbunded area. And if we're thinking about our store as well, lots of different stores you can have. You can buy purpose-made stores like in the top right. You could make your own block building within the filling area, or just a smaller cupboard. But it's important to think about fire risk, and the idea is that you would have a floor and you would have walls that would be fire resistant for 30 minutes, but you would have a roof that would be able to collapse in. And this obviously makes it a lot easier and safer to contain a fire or to fight a fire that way. Just mentioning a little bit now about waste exemptions. So you would need to have a T32 waste exemption, and this is for the treatment of waste in a biobed or a biofilter. Now, this is those Environment Agency waste exemptions that you fill in every 3 years, and they include things like spreading waste to land, for spreading, digging out ditches, spoil onto land, and burning hedge cuttings and that sort of thing. So it is a free waste exemption, and basically it means it is an exemption to having to go through waste permitting procedures. The things to think about are you want to have a look on magic maps to check if you are in a source protection zone. So the source protection zones are really designating how long it would take for water to reach an abstraction point. And the one that obviously is the highest risk is the red. So this is the inner protection zone around that abstraction point. If you are in a zone 1, you will need to speak to the Environment Agency about your plans. And again, obviously, if you're proposing to do something which is safer than something that you're doing now, then that shouldn't be an issue, but that is a compulsory part of the process. If you're in any other area, then you don't need to do that. There is also a waste exemption if you're using a Sentinel unit, so that this again is the carbon filtration, and then the sludge and the filter is disposed of by waste contractor. There is also a waste exemption, which is a U10. So this is spreading waste to benefit agricultural land. So you would need to register this to be able to dispose of the used biomix. So you're needing to replace that every 5 years. You want to store it somewhere for 12 months, and then it can be spread to land as you would do with FYM or anything like that. So that sort of summarises the main things to consider. I would ask all of you to have a think about, are there things that you can do now if having a dedicated area is sort of in your future plans, but it's not something that you've got at the moment. So the first thing would be to use a drip tray. Always use a drip tray. Doesn't matter where you're filling, whether it's in the yard or whether it's out in the field. And we want something nice and big. So that drip tray under the induction hopper in the top left, I would say that's a bit too small. I prefer something like the bottom right. So it's a cut down IBC. It's got a rope handle on it. It's really easy to slide under the induction hopper. And so if we have any sort of splashes or drips or anything like that, it's going to contain those. Now, if you have got a drip tray, make sure that you store it under cover. So usually the most sensible place is to put it in the chemical store. Obviously, it's not going to do any good if it's left outside, and then it can fill with rainfall and so on. Having a drainage rack that will contain all those residues after you've triple rinsed your containers, I think is a very good idea. Again, the bottom left, a cut down IBC with a rack in the top works really, really well. And if it's somewhere that can be undercover, tucked out the way, then there's no immediate rush to be able to package up those containers. If you've got plenty of space, then by the time you put them into the container or bag to have them taken away, they will have emptied out all of the liquid. So just a few examples of sort of things that I've seen on my travels. So that first picture there, it looks like it's it's an okay setup. So they were using a drip tray. There were a few containers about, which was far from ideal. However, that little shed that you see just beyond the filling area is actually a borehole, and that was a borehole that was supplying houses and also a cheese making facility. So obviously that's a real no-no there. So not good siting there. What this farm did is we found an area that was tucked out the way. It wasn't a trafficked area. It could be a dedicated area for the sprayer, and that was much better. The one on the top right there, this was one that had obviously an uncovered filling area, and then there was an offset biobed. The location wasn't great because it was right next to the sort of access to all of the fields on the farm. So you can see there's a lot of mud there. So it meant anything going onto that pad was muddy, that there were problems with pumps and silt trap getting filled up very quickly. And actually on this one, you can see that the bund around the outside is very low. And in events of heavy rainfall, water would actually come down that track to the side, wash over the pad, and then go over the pad at the bund at the end. So that wasn't ideal. Again, just a little bit of thought into the location is a really good idea. So top left there, we can sort of see the problem there. We were filling right up on a very, very busy yard. So there was livestock, there was straw, there was machinery, a workshop and so on. There was a lot of broken concrete, which meant it was very difficult to keep clean. Drip tray wasn't being used either, so not ideal. And actually what we were able to do is to have some concrete yard renewal, which made that yard a lot easier to keep clean. And we actually located the filling area in the chemical store beyond the last building. So it meant it wasn't being trafficked by anything else. It was very easy to get to, and we didn't have the issues there. You're probably wondering what that picture is doing in there with the cattle in there, but this was a farm that I went to. We had a good filling area outside. It was actually a bunded area. We had a biobed treatment system, but our chemical container is right at the end of that feed passage. And to get to it, we had to walk from the outside yard through the cattle race, through the cattle crush, along to the end of the building and then along that feed passage. So in terms of security, it was very, very good. In terms of having to move chemicals by hand, it made it very, very awkward. So again, you know, they didn't store a lot of chemicals, so a little purpose-built container cabinet type that was secure on a corner of the pad was ideal. So we've got a typical biofilter setup there. That's typical of the kits you can buy. So there's a couple of manufacturers that you can buy kits. They've got the 4 IBCs, all of the pumping and the pipe work. So all you need to do is to create the biomix to put in it. Now, I'm not so keen on that one there, but because it's actually outside the building. So we've got a couple of issues there. One is it's not on a bunded area. So if, you know, I know it's unlikely, but if we had a leak or a pipe connection blew or something like that, then potentially those washings could go down past that concrete pad and then onto ground, or maybe into drains. The other thing, if we've got a biofilter, I much prefer it to be in the corner of the pad under cover, because again, we want to keep that biomix alive and doing its job. We don't want pipes to be freezing. We don't want the biomix to be freezing. So under cover is definitely a lot better. That one there, so that this was quite a large farm, had a lot of chemicals. This store, it had sufficient bund capacity, but it had sufficient bund capacity because of that lip at the front, which was you sort of well past your knees. So it made it very awkward to go in and out. It was very cramped. If we had any sort of spillage, then we've got cardboard boxes and that sort of thing in there that were going to absorb up the chemicals. So a bigger purpose-built store was a better option for that farm. Then that one there, your chemical store, really important that it is just used for storage of chemicals. That's rather disorganized. We've got other things in there as well. We've got fuel, we've got machinery, so there's source of ignition in there. So again, not very safe. We've got a wooden floor there, and I'm not keen on anything wooden, whether it be floor or shelving, because obviously that can absorb chemicals. So there was an opportunity there to be able to tidy that up and have a designated area. This is the one that I showed at the beginning of the presentation. So this is a good outside bunded area. And obviously we can see that we've got the height of the bund there. We've got a big drain. We had a biobed system, so that was all very positive. The thing that lets it down is we have got our chemical store that is not right up to the bund. So we would be going from the chemical store with our chemicals, walking across an unbunded area, which sloped down to a yard drain. So I would have had that container right up against the bund there. So we're not having to walk on anything unbunded. Okay. So that concludes my presentation. Do we have some questions, Elizabeth?
Yeah, we've had a couple of questions, but I think you've answered them really well, Mel. So the first one was about dealing with the waste from the biobed or the biofilter. I think you went through all that very, very clearly. So I think you've answered that one. And the second one was about the use of the biofilters outside. You just mentioned that you prefer them undercover because of freezing. Is there also a problem with rainwater on an outside biofilter?
Yeah, I mean, usually I would have, whether it was inside or outside, I would just have a little lid over the top of it, so you would be excluding rainfall. I mean, I suppose actually the other thing to think about would be if it was very hot, then it would dry out that biomix as well. So and because we're just talking about just 1 cubic meter, it's easy to sit that in the corner of a pad out the way.
Yeah, okay. Yes, so we don't have any other questions at the moment. Do put them in the Q&A if you have any.
Sorry, we did get one submitted via email.
Oh, right. Yes, do you want to give that one?
If she's got any answers.
Yeah, well, it was just about security. And I mean, if you're thinking about location, I would want it, the setup located as close to farm buildings as possible, or close to a house, obviously, if the house isn't using borehole water. I mean, the sprayer is probably the second most valuable piece of kit on the farm, so it makes sense to have that close by. And with the cost of chemicals, again, security is really important, and that's where I would prefer to have a building that was secure, and then within that have a chemical store that was also separately secure. Yeah, that probably covers that really.
Nothing else is coming through. I have to say, every time I thought of a question, you answered it. So I think it was very, very thorough. Thank you very much. So
I'd probably just say that,
yeah.
Again to everyone that there is so much free advice available, and you know, it's all confidential. No one's judging. It might be me, it might be someone else who comes out, and we can talk through what you're doing. You know, sort of, are there different options for you? Where would be the best location? How would we design the setup for you? All of that information is there. They're free, and we can give you all the information on how the catchment fund works with Thames Water. And I probably should say as well that a big part of that is rainwater harvesting. So it's a really good thing to add on, particularly if you're either using an existing building or you're putting up a roof over a sprayer filling area.
Right. And we have had a new question, which is that, can you spray out the contents of the biofilter rather than have the cost of an irrigation system?
Yes, you could. Effectively, it needs to be used. So if you were spraying it out, then effectively it would be the same as irrigating. I'm always a bit cautious about that, because with the sort of best will in the world, you're still going to have bits of, you know, silt and sediment and that kind of thing. So I wouldn't be very keen on putting that water back through the sprayer. If you've got a biofilter system, then you can just keep circulating that through. So I would say, if you've got a covered area with a biofilter, you won't need to get rid of excess water, because that living biomix, it's evaporating and absorbing water and so on. So you'll find that you will need the liquid.
Right. I mean, presumably that the irrigation system is helping it to just go out gradually, rather than, you know, if you just let all the water go and have a nice waterlogged area. Yes.
Yeah, exactly that. And if you weren't having an irrigation area, you would need to make sure that you had a big tank, because you know, when it needed to be taken out, it might not necessarily be the right soil or ground conditions to do
right.
that with a tanker or with a sprayer. And you don't want to be in a, you know, where you've got a float switch or something that's alerting you to the tank being full, and it's not a convenient time to get rid of it. So I would rather have myself a completely sealed system, or a system where we have that irrigation, so it's gradually taking out that water.
Excellent. Right. So unless anybody is coming up with a new question, I think that's everything we wanted to do. I will just so I think still no extra questions, so we'll leave it there. Thank you very much, Mel. That was very, very clear. And thank you all for attending. Right.